Good morning, everybody from sunny Zagreb, Croatia. And I wanted to start today with this nice view that we have from our building in Zagreb. You can see it here, so nice blue skies, but also in the south, in Split, in Dalmatia, blue skies as well. So we have quite a nice sunny day today in Croatia. Not much interesting when weather is concerned today. If we look at today's situation, I must first of all apologize. This is the satellite view from our station because the ePort today did not have satellite images, neither at 6 but also not at 0 UTC. So I based my analysis on yesterday's images. If you look at today's situation, you will see that we have quite some area of nice weather here over Mediterranean, Central, Eastern Europe, and some weather, I would say bad weather developing over northern parts of the continent, which is actually a consequence of quite a big and well-developed low system which is placed over northern Europe, whereas the southern parts of the continent are under the influence of the Mediterranean high or even the Atlantic high here. So the high pressure area spreads over mid-Atlantic Mediterranean towards Eastern Europe. Of course, the northern parts of Europe will have much worse weather than the Central and Eastern Europe also today. But before I analyze the images from yesterday, where I found a nice conceptual model, I would like to start this analysis with the situation from the end of last year, since we didn't have weather briefing in the last days of December or last days of last year. I could say that we all remember that December was quite warm. It was according to the seasonal forecast, and it really approved the seasonal forecast, which said that December will be quite warm. I show you here the data for Croatia because I don't have the data for all Europe, but I believe it was pretty much the same in all Central and Eastern Europe, that December was rather warm. In our parts, it was even in the category of very warm, as you can see here in these parts, and warm in the other parts. So after very warm December, winter actually showed its teeth right after Christmas. And I believe you all remember the images from the snowstorm that occurred after 26th of December. Actually, it started on 26th over the UK and then moved towards Europe on the 27th and 28th December, and even as far as Albania, so southeastern Europe, where it also brought some snow. What was the consequence of the situation? Were heavy traffic jams, some human casualties also. You can all, I believe, remember the images from the news where the in France people were trapped trying to go home from the skiing resorts, were trapped in snow. If we analyze the synoptic situation that was connected to this cold air outbreak and snowstorm, actually it all started on 26th December. But if you look at the air mass image on the 26th of December at 12 UTC, what you can clearly see is the jet coming from the north, far north, bringing very cold air here from the north. And also this cold advection here is pushing against the warm advection in this area. So the system started to develop actually over Ireland on the 26th of December at 12 UTC. Already at that time, or just slightly after, we had some snow over England. At that time, what could also be seen is that the air that is being advected from the north with this jet stream coming from here was actually very cold. And if you look at the IPV values, you can see that this is the air, which has quite high values of potential vorticity. So the system is actually coming from the north and will develop further on over British Isles. In the next 4 images, I have just briefly shown the development of the situation, because as you can see, already at 18 UTC on the 26th of December, you already have the signs of the development of the small pressure low in the low levels. The black lines are the mean sea level pressure lines. And only 6 hours later, this system has intensified. The cloud spiral is already quite nicely seen, and the system moves further towards the European continent. So the snow that was falling in the afternoon hours on the 26th of December over England has already during the night moved over Western Europe, and here the snow started to fall also in northern France, Western Germany, over the western coasts of Europe. 6 hours later, the system is already almost over Central Europe. You see that the low is getting even deeper, and then it crosses the Alps on the 27th December around noon. It was bringing snow all the way down. Excuse me. It was bringing snow all the way down, and if you look at the products that show the precipitation probability, you will see that nowcasting soft precipitating cloud product clearly show that the clouds were precipitating all the way down. It was strange because when I was looking at, for example, multi-sensor precipitation estimation from MPEF, it only showed snow, or it only showed precipitation in this part over southern Alps. Did not show any precipitation over Germany, for example, which was all in form of snow. So it might be that the product has some problems with somehow retrieving the precipitation, which is not rain. Because if you look at the synop measurements, you will see that all this precipitation fell in form of snow, and it was quite heavy snow, which brought some centimeters of snow over all these parts. Further on, if you look now at the upper level situation together with the surface low, you will see that there is a cutoff process in the upper level at 500 hectopascal. These are these green lines. You can see here the surface low, 2 centers here and here. And if you look more closely, it is quite small, but you will see that here you have a cutoff low at 500 hectopascal, which is quite nicely correlated with the surface low. And this system was very intensive, bringing heavy precipitation. As you can see, at 28 December at 6 UTC, it was still snowing in southwestern Germany, southern Poland, over Czech Republic, Slovak Republic, Austria, Croatia, Slovenia. So it was quite heavy snow in all Central Europe. This was a very interesting situation because the cyclone developed very rapidly. So from 26 at noon to 28 at 0, it already passed over almost all, so definitely over all Western Europe, and was moving towards Southeastern Europe. After the low moved into the Adriatic, besides snow, we also had some very strong wind, even extreme values. So it was quite a nice system with a lot of precipitation on the way. If you look at the quantities of snowfall, I'm sorry, I have only the values for Croatia, but I believe it was pretty much the same also over Austria, even more, and over Germany. And if you look at the values here, you will see that in 24 hours it was 40 centimeters, 30 centimeters, above 25 centimeters in many places. So it was quite high values of snow falling in these 24 hours over our parts of Europe. Wind, which was following. So wind was actually very interesting. If you look at the values for Split, this is the station in the South Croatia, in Dalmatia, on the Adriatic coast. You see that we have two peaks of the wind, here and here. These are the, on the first graph you see mean 10-minute mean wind speed from the automatic station. And you can see that first we had very strong southeasterly wind, which preceded the center of the cyclone, and after the cyclone moved into the Adriatic, then we had extremely strong northeasterly Bora wind, which had values of the mean wind up to 25 meters per second, and here you can see the gusts, which were up to 40 meters per second, which are quite severe wind gusts. So this was this, I would say, Christmas storm. It happened a little bit after Christmas, but it was interesting. At the same time, there was also a very interesting snowstorm in the US, but the time does not allow me to go much deeper into the analysis of that. But at the same time, we had a very interesting situation also in the US. I believe you all remember the images of very high values of snow over Buffalo and other parts of US, which were at the same time as this Christmas cyclone over Europe. Now, let us go back to a more recent situation. This is actually, since I couldn't find the image from the ePort, I have downloaded the image for 7. This is just an hour, just before an hour and a half, at 7:45 UTC air mass RGB image of today. So what actually do we have today over Europe? Still a big low system producing cloud systems over northern parts of the continent, and in the south. In the south, we have still mostly the influence of the high pressure system, with the remnants of the low this was actually a front that passed very quickly over the Alps 2 days ago, and it also brought some snow showers, even some thunderstorms. It was the night between Sunday and Monday in Croatia. It was very interesting because it was lightning and thunder like in the summertime, and then the snow was falling, but it was all very quickly. The cyclone moved to southeast, and now we can still see the remnants of the upper level low over here over Eastern Mediterranean. So not much interesting over Central and Eastern Europe, mostly clear weather, I would say nice weather, even spring weather, because the upper level stream of upper level advection is warm, coming from the Atlantic and bringing quite some warm air here. The system developing on the Atlantic will be interesting in the next days only. So this system here will be interesting in the next days only to the most western parts of the continent. The front will produce some precipitation over the western parts, but will move towards northeast, not entering the European continent. What I wanted to show you was actually the situation from yesterday, because, sorry, if I go a little bit back, you see here the remnants of of a system which was much nicely seen yesterday. Here it is. This is obviously some warm air coming from the southwest. And if you look at the image from yesterday, then you can clearly see this nice system here. It is a very typical representation of the system, and you will see now the key parameters connected to it. So what you could see yesterday was a jet stream flowing from over the Atlantic, and here over this cloud band, some very cold air protruding from the north. Here you can see the nice cold air development, cold air clouds over the Atlantic south of Iceland. What else was interesting? This is still, so this was also yesterday, that the Northern Europe was under the influence of this big low system, and this will remain so also in the next days, whereas the southern parts are under the influence of the high pressure system. There are some there was still a surface low over the eastern Mediterranean yesterday. Today it is already dissolving. In the upper levels, you can see at 500 hectopascal, quite intensive here, southwesterly stream over parts of Western and Northwestern Europe, mostly bringing warm air to the European continent. Cutoff low over southeastern Europe yesterday, also very prominent. What I wanted to concentrate on is this cloud band that we saw. So this here, as you can see, there is a prominent warm advection in the head here, cold advection coming from the north here behind this cold front. So if we would analyze it properly, then we would say this part is definitely a cold front, and this part here is a warm front head. If you look at the other parameters, here is the thermal front parameter showing the line of the frontal zone. You see that in the warm front part, the clouds are mostly behind or to the west of the frontal parameter, whereas in the cold front it's mostly in line with the thermal front parameter. The system itself has in the infrared image mostly high clouds, high and mid-level clouds. I will show you later the microphysical image to see which type of clouds it is, but it is white, so it's obviously a lot of ice clouds in this cloud head. So according to the manual, if you look at the water vapor image, it is also white in the cloud head. So according to this SAT-MANU, you should have white appearance in both infrared and water vapor image here, whereas in the visible image there should be some lower clouds or less water content clouds here in the back side than here in the front side, according to the let's say a typical situation. Oops, sorry. As for the other parameters typical for this conceptual model, you would have the equivalent thickness, which has to be dense here in the area of thermal front parameter. So if you look at the green lines, this is in accordance with this conceptual model. So you have nice dense green lines here over the let's say southern or more eastern part of the front, and this is typical for this type of the warm front. Also, what you can see from the advection and the jet, that the jet is really showing the maximum on top of the frontal cloud band. So here in this area, as it is also shown in the typical example, and the warm air advection maximum, which should be present in the cloud head, is really present here. So a very nice typical example of, I have one image missing here, I'm sorry, but I'm showing you here the cross section, which actually goes, it's something like this, something like that. I'm sorry, I don't have the presentation of the line, but it is going through the cloud head, ending in the warm front part. And you can see very nicely the isotopes connected. Sorry, the isotopes connected to the warm front, and also very clearly the warm advection maximum above or within the frontal zone, which is clearly connected to the warm front. Very nice example of the warm front. Also, the isotax are located exactly as it should be. In the ideal case, the isotax are here on top of the frontal cloud band, and you remember that they nicely follow the northern edge of the frontal cloud band. What it is actually in the microphysical RGB, you can see that the cloud band is consisting of both high and both ice and water clouds. So this part here is mostly ice clouds. There are some ice clouds also in the other parts, but I would say in the back side, there are also quite some water clouds. And then if you remember of this typical distribution, you should have white in the white clouds here in both infrared, water vapor, and visible, and some less white invisible here. It is because these clouds are not so dense. There are much more water clouds here than in the let's say leading part of the frontal cloud band. So altogether, a very typical example of the warm front band. If you look at the weather events which are connected to this warm front, you can see that in the ideal case, you would have some rain, some drizzle, also some heavy rain in the behind the zone. You could have some ice, so some freezing rain or freezing drizzle behind the frontal zone. And if you look at the synop measurements, then you can see that you indeed have some rain, also some light snow in the area of the frontal cloud band, but in this case much more in this leading part than behind. It could also be that there are not so many synop stations here in this let's say back part of the front. Altogether, a very typical example of a warm front band. If you want to go through the details, there is a conceptual model on the EUMeTrain web pages under Satmanu chapter, under Satmanu link. This is now, for those of you who did not see it yet, this is now a new appearance of the Satmanu Manual of Synoptic Satellite Meteorology, which I would really suggest that you go through and see whether there is something that you can find which could be, I'm sure there's a lot that you can find which can be useful in your everyday work. So anyway, the manual now has more modern and nicer appearance, and thank you, Isolda. And I believe you will like it, so go through it. Just to sum up and to end this discussion today, I'm going back to the image from this was 8:45 this morning. This is again the situation from today. what I wanted to show you was what it will be in the next hours and tomorrow. So what we have here is, to repeat, low pressure system over the northern Europe, some high pressure over the south and eastern Europe, a big system coming from the Atlantic here, the frontal system, which already has a quite developed cold front, warm front, occlusion cloud band. So you can see already that the low is somewhere here, surface low, and this will move. This will move in the next hours towards Western Europe, but then it will not go into the European continent. It will move towards northwest. If you look at the forecast image for tomorrow at noon, this is the mean sea level pressure and temperature for tomorrow. You can see that the low pressure center tomorrow will be over a little bit north of the British Isles, and then it will move towards northwest. What is again expected over European continent is quite some warm air here in the west. You can see that the temperature, this is the 2-meter temperature, it will be above 10 degrees in many parts of the Western Europe, also even above 12 degrees here in parts of France. And across all the Mediterranean, so quite high temperatures for this part of the year. So again, we have warm air coming towards our parts, and I see here that I'm missing several slides, so I cannot show you everything that I planned. What is also interesting is that I will try maybe to show you this, but I have to. What we can expect is some warm air in the next days, in the next few days, warm over all the Western Europe. This is now the upper level situation. You can see here that the warm air is advancing from the southwest towards all the Western Europe. So we will have some above average temperatures in the next days. But then what happens is that from the Atlantic here, I don't have it in this image, but some cold air is advancing from the northwest, from the Atlantic, and this will come during weekend to the Europe, and then next week we can expect some cooler weather, some snow next week, and I hope that these that like snow will like it, because next week we could have some snow, not a lot, but at least some on Sunday and Monday. This is what it looks from the forecast charts.